Hi class, name is Jim Wilson, Math 3353, giving you a video presentation of a lesson plan I turned in last week concerning how to obtain the area of a circle. The area of a circle is basically the surface face area of the circle. And to demonstrate that, I'm going to start off with three small circles. Common circles, we have a dime, we have simple quarter, we have the bottom of a glass to represent three different sizes of circles. And they're pretty round, so they make it easy to figure out what a circle is. Now I have taken those circles, and I will instruct the class, my students, to put them down on a piece of paper and take a pencil and trace the outline of these things so that we have three different size circles. And I'll ask the students to point out which is the smallest, which is the largest, and the in-between one. That way they get an idea of what circles look like, and idea of circumference. We'll explain to them that a larger circle, such as this one, has a larger circumference, or in other words, a perimeter around the circle. And the smaller one here would have a smaller circumference because it's a smaller circle. Now, to get to that point, we take a look at this graph I have to figure out a ratio. A very important ratio is circumference over diameter, and that equals an irrational number known as pi. You can look at here in our y coordinate system, we have circumference, and in the x we have diameter. Two very important parts of a circle. Take a look here at my chart. We see that we have pi, which equals, as a ratio, equals circumference over diameter, which is an approximate of 3.14. We use 3.14 as a standard approximation for it, for calculations, equations, so on and so forth. Stress to the students that it is an irrational number and does not have a set value past that point, and it never will. So, a couple of key points here. C stands for circumference, D stands for diameter, R stands for radius, area, circumference formulas. A little quick diagram that I'll draw up on the board for them to give them an idea of the facts about a circle. The circumference is the perimeter or outside edge of the circle. The diameter is the width of any 2 points across the circle. Radius is only 1/2 of one of the diameter. That leads us to our formula for area, which is pi, which is the ratio of circumference over diameter, times the radius squared. The circumference is pi times the diameter. You see a nice little relationship there. Would be pi times radius squared. So getting back to our diagram, we have a circle, and for talking's sake we'll say it's 2 inches across in diameter. If we punch in our numbers here, pi for the area, for the circumference, we'll start off with is pi times diameter. So the diameter is 2 times pi, which is approximated at 3.14. We get 6.28 inches all the way around. That's the circumference of 6.28. However, the area, the surface area of that circle inside of it, is pi times the radius squared. So the radius being 1/2 of the diameter here, 1/2 of 2 is 1. So we square 1, we're going to get 1 again. 1 times 1 is 1. multiply it times pi, 3.14. 3.14 times 1, of course, equals 3.14. So our radius, our area, based on our radius, our circumference, and pi, is going to be equal to 3.14 square inches. And that can be applied to any circle. All you need to know is the diameter, circumference, and you can get the radius from the diameter. That's all you need to know. This formula right here, pi r squared, will tell you the absolute area of a circle. Now, drop it back to our board here. We clear off all of our formulas and such. We're going to do a real-world application of area of a circle. A very important device is called a parachute. Parachute is basically a circle that built out filled with to a weight.
Parachute's a big circle. You have to be able to calculate the area, surface area of that circle, so that you can determine if it's going to be big enough to catch enough air to slow down the descent of an object against the pull of gravity against it. So what you have to weigh is force of gravity and amount of surface that catches enough air to balance that, or to counteract that, slow the device down. Once you figure that out, you've got yourself a good parachute. And that's what we're going to do today. Show the students how to make their own little parachutes. To do so, they must have a pretty good solid grounding in area of a circle. And after we explain the area circle and get them work on it a little bit, we will get them some masking tape, some thread, have them bring in a small little figurine of any size, preferably in the 5 to 10 grams, just an ounce or less than an ounce. They will need a pencil, graph paper, some heavier paper to cut out at a later date and trace on, and of course plastic shopping bag. This type of plastic is perfect, lightweight. They will trace their circles that they make on the paper onto this, cut it out with a pair of scissors, and then they will take some tape, cut some strings, 6 inches long strings, on with the thread as such, attach it to their figurine, either by tying it on or taping it on, and then taping the other side of the string at equal points on the bag, so that you have a nice fluffy parachute coming down. Now our key points here is that some of the students, and we'll put them in groups 3 or 4 so that they can work together. They will somewhat. Now I want to point out the assessment that I would use is they do have to create a workable parachute, and they have to show the calculations they use to come by it. The diameter, I need to see the diameter. I need them to tell me what the radius is, and hopefully they didn't forget that's only just 1/2 of the diameter. And then they have to calculate for me the circumference and then the area. I want to see all of these details for each one of these group little parachute projects. And a couple of questions I'll probably pose to them is, what happens if you made it bigger, smaller? What do you think would happen if you put multiple parachutes together and see what what would that do. You can let them thinking about multiple surface areas. So I think it's a good project. This is for Math 3353, video presentation of a lesson plan in calculating the area of a circle. Thank you.